Does anybody have the thingy that converts from that to USB-C? Yeah, but USB-C, HDMI. I've got one up in my room, but. Okay. So. Pardon? Oh, okay. Couldn't see. Okay. We're usually paying around $1 million. Great. I'll be right back. Come with the show. Weren't we here together?
Well, I think the guy who started was like pretty dry. Yeah. You know, so I think that's like, well, contrast is easy. Let's whip this room up. We didn't know if they understood that. They obviously did understand. Well, I was throwing memory sticks at him. I think that helped. What is the time? Oh, it's right now. Oh, crap. Okay, hey, let's do this. Do I have a co-chair? I don't have a co-chair. I have just me. All right. Before I whip this stuff out, so we need a minute taker. Making eye contact with somebody here. Someone? We can't move forward. There we go. Perfect. Thank you very much. You can do it from back there, but it's nice if you're up front. You can ask people, get their names and all that. Remember at the mic, speak your name first clearly so we can track who said what when, and we could get our ops ADs very happy about getting our stuff up and on. Yeah, you can join up there. Is fine. You don't have to sit up here, but if you want to, go right ahead. We got a chair. You just have to listen carefully and. Oh, we got Jabber too. Fantastic. Look at that.
You have all our slides.
What?
You have all our slides.
I don't have your slides. No, I got my slides, and then you take over when I'm done.
No, I mean, you have the slides for people that presented.
Yes, I have all the Mboned slides. Greg, are you doing your job? Was that the question you asked? Okay. Okay, that's gone. And what's that? Video adapter. Look at you. You're the best.
Were we? Super excited about it.
That's not very well. I can probably have one. Sorry. Throw it in. Doesn't mean I did.
HDMI right
I
here.
got it.
Ooh, oh, right there. HDMI port, yeah. I don't think you need that. Really? Right?
Oh, I don't know. I've never used that.
Yeah, here.
Okay. I know this works, man. I know this works. No, that doesn't work.
Okay. It doesn't work.
No, that's half. Oh, no, you're right. It's 40 lines.
Yeah, man.
Whoa.
Whoa.
You have the power.
I'm just gonna co-chair this session.
So what I say? I said you're the best, right?
Nailed it.
So, I didn't even need the adapter, so I have nothing to chase down or anything. So you are in Mboned. As we do, we co-host this with the PIM group because we find there's a lot of overlap, a lot of the same body count, and that way you don't have to work on any conflict problems, right? We just all sit in the same room. So we got Jabber, we got a minute taker, gjchef@gmail. So send that to me, or even chairs at Mboned when you get it. So I'll know to chase it down. All right, let me get to present mode here. I'm formally not on the mic.
They're very direct.
There we go. Oh, it's very. It's like right in the head. I am your father, Luke. You hear me? All right, great. Isn't there like a? Oh, there it is. Slideshow. Bam. Agenda. Excuse me, sir, in the front. You that smells like beer. Thank you. You guys want to work on your tools outside? You can do that. Anything missing from the agenda? Out there? He didn't put the note well in here. There's the note well. Note well. Noted. Noted well. Excellent. So we'll get to that next. So first is Mike McBride. Anyone seen Mike? Yes, the handsome guy. That would be you.
I need to stand right here. Oh, yeah,
Yes,
very good.
stand inside the pink. Closer, closer.
Hello.
You need a pointer?
I don't. Okay, so this will be one of the more exciting moments of Mboned. The rest of it will be a little bit slow.
It opened up at the end of your presentation. I started back.
Yeah, that's good. All right, so just a brief history of this. So it's been 2 years since we first wrote this draft. We kind of lost interest, and for a variety of reasons, we haven't really been spending much time on it. But in the last 6 months, as Michael Iverson and others know, there's been, for whatever reason, a kind of an acceleration of interest in this topic, multicast over Wi-Fi, and acknowledging the problems that exist in that medium. And we had a meeting last IETF, kind of a side meeting-ish kind of a thing to kind of discuss some of the issues and what we should do about it. So we revived the draft. And in between you can go to the next slide, Shep. But actually, yeah, let me step back and before I get into that. So just a reminder of why we're doing this work here at Mboned. This is the perfect place to do this kind of work because as the Mboned charter says, is that we should receive regular reports on the current state of deployment of multicast technology and create practice and experience documents and provide feedback to other relevant working groups. So we feel that this topic is a good thing to do here in Mboned. And my question that I'll ask at the end of my time here is that we should adopt this draft into this working group. And so in the when we get to the next slide, I can talk about some of the things that we get, which is fine. In between the last 2 years, Charlie, my co-author, he also wrote a similar draft. He proposed it to the INT area working group. He described the INT area, which I'm not involved in, that as kind of a catch-all for these kind of things. And he and I discussed, now that we've had renewed interest, that Mboned is the appropriate place that we feel that this should be done in. So this is the multicast experts. We're not the Wi-Fi experts, but we are multicast experts. So that's why we feel that it should be done here. And he, in fact, in this other draft that he wrote, is asking the authors to take that information and put it into the draft that we have here. So just a reminder, some of the issues, Michael may know of some other ones that I may have forgotten here, but there's issues with using multicast over Wi-Fi. And part of it is that there's just low bandwidth over 802.11. There's increased congestion, which causes a high packet error rate for multicast streams. Poor reliability. There's no acknowledgments for multicast packets as there are with unicast packets over Wi-Fi. V6 neighbor discovery easily saturates the Wi-Fi link because it uses multicast. And apps like Bonjour that does a service discovery for things like printing services can saturate the link using multicast. And it kind of was agreed in the last meeting that we had that these problems will not be fixed anytime soon. Dorlis.
Yeah, Tolles Eckert. Are the two lower ones not hopefully just slowly going away by themselves through faster and faster Wi-Fi? No? Why not? I mean, if the speed of the link gets faster versus the number of these packets.
Michael Abrams here. So the problem is that it's sent at the lowest common denominator rate as to everybody. So typically, even if you have like 1300 megabits of unicast, this will be sent at like 2, and everybody's listening to it. So that speed is not really going up, that lowest speed. If someone's on the edge, this will be going at that rate. So it can be 1 megabit, and it has been for a long time.
Right, but it's kind of bringing down
Dorlis, just names between them so
Yeah.
we can follow the conversation.
Yeah, Tolles Eckert. But it's bringing down the link to that lowest speed for the duration of this, and for the remaining duration, it goes up to the maximum speed.
Yeah.
So the higher the maximum speed is, the higher the total throughput of the remaining time.
There is another issue also is that so let me put it this way. This problem is so bad that a lot of mobile devices actually do not listen to these packets at all when they're sleeping. They just, in hardware, just drop it. They don't even wake up the CPU. So this is there's a problem where on some phones, if you have anything where you need like push or pull over V6, it just stops working completely.
Okay, but that is a fourth problem, which is battery problems.
Yeah, and that's in the draft. Yeah.
Yes. So there are multiple reasons here. So this problem is, there's nothing telling me that this will be fixed in the next 3 years, and most likely it'll take a lot longer.
That's right.
Stig Vennas. So yeah, I didn't realize, or I didn't think that that was the main issue with neighbor discovery, like the amount of packets or the bandwidth. But
Closer to the mic? Can we get closer to the mic?
Yeah. So I didn't realize that the bandwidth was a problem, but yeah, this is a problem that like a phone or whatever doesn't really want to be woken up every single time someone sends a neighbor discovery packet.
Yes.
So what they often do is to not listen to all of them and then you drop them. The other problem is, I think, the reliability. You're quite likely to lose some neighbor discovery packets, which is pretty bad.
Okay.
So yeah, Warren Kumari, kind of related to the last thing. Who remembers the Prague meeting? Not the last one, the one before,
Yeah.
when all the wireless was kind of sucky.
Well,
A significant amount of the reason for that was just simply there's a lot of ARP traffic, and it turns into multicast and it saturates the link. So yeah, it all goes at the lowest possible speed, which makes everything sucky. So this is actually a problem which we see in the real world as well. In many cases, actually, the APs just start dropping ARP or neighbor discovery because they only will send a certain amount of multicast.
Stig Vennas again. I'm kind of wondering though, with some of these technologies, why the minimum speed wouldn't possibly, could go up a little bit.
right in the mic. I'm
Anyway.
having trouble hearing. Do you say that again, Stig? Stig, was hard to hear you.
Stig was wondering why the minimum speed can't go up.
Oh.
Joel Yeagley. So it has over time, but it's several orders of magnitude slower than the maximum speed, which means the time domain in which the minimum speed window occurs is several orders of magnitude longer than, say, the transmission for the same packet at a different rate. So like other things become unavailable to you, like, for example, beamforming and certain kinds of time domain shifting that you do at the higher rates that you have available. So this is actually driven by backward compatibility with the minimum speed device that is or can be attached to that particular network segment. So over time, that has actually gotten faster, but it's, like I said, in some cases, 3 orders of magnitude difference in performance.
Okay, thank you. So,
Yeah, let's bounce on.
yeah, so let's do. So, move to the next one. So again, with all those comments, again, it's our feeling that it's important to gather that information. Not that we're going to solve it, but it's important for the community to understand the problem. So there are some workarounds. This is a problem statement draft, not a solutions draft. But we felt it would be helpful to at least show some areas where there have been some workarounds. One thing that's been around for some time is a conversion of multicast to unicast packets, which kind of defeats the purpose of multicast, of course, but it is useful because the unicast then gets acknowledgements and it's more reliable. Maybe we could provide a acknowledgement for multicast packets. Traffic classes may help. It was described in our meeting last IETF. Maybe a reliable registration to L2 multicast groups and a reliable multicast operation. And as Torlis mentioned, there's work being developed to help save battery life here in the IETF and other places when not waking up when receiving a multicast packets. Next slide. So some of the comments from the list, and again, the draft, if you're interested in this, please read it because we just kind of try to capture basically the notes from the meeting. And some of those comments were that we need to determine what the problems should be solved by the IETF and what problems should be solved by the IEEE as much as we can in a somewhat high level. Maybe IETF decides that broadcast is just more expensive, so multicast should be sent over wired. I mentioned kind of added a class of service to multicast packets. Determine performance requirements for multicast. I'm not sure if that's something that we need to get into, but it's certainly something we could consider. And then another comment about private area networks as well. Next slide. So this is the last slide. So the next steps. We should consider identifying problem areas in IETF protocols that may be affected, and some of those were mentioned just in the comments. Identify reasonable workarounds. There is a mailing list that's not being used very much. It is right after these meetings, but then it just kind of goes quiet because a lot of people lose interest in this. But there's a mailing list you can join to discuss this. And it'd be interesting to see if this group full of multicast experts feel that this is an area that we should be working on. If it is, the authors have committed to actually not letting it go and to actually be actively working on it. So we'd like to consider it be adopted by this working group.
Quick, Torlis. We're going to time. Stop.
Really? Okay. Yeah, I mean, I would love to see that maybe the scope is not kind of that limited because you mentioned, you know, a bunch of workarounds and possible ideas. And, you know, if it's just, you know, kind of a problem statement, and then it might be limiting us in doing, you know, the text, you know, outlining possible ways to solve the problems, or even in cases just, you know, simple attempts to provide BCP information, like, you know, raise the minimum bit rate that you've configured on the access point, right? Which can in many cases be done, right? So maybe if we change the title to be a little bit more open.
Well, yeah.
I wanted working group document, yeah.
All right. So just as chair, I want to ask a few questions and give a little direction. Who was here at the kind of ad hoc meeting after Mboned at Prague last summer? Wow.
Michael, you were
Okay.
there.
Because
Yeah, you were there.
yeah, I found that as an eye opener. I mean, all the focus we're talking about here is really, for the most part, is the fact that multicast is not acknowledged and doesn't get retransmitted. So you get a loss problem. We're going to focus on loss, you know, tolerance, but that has nothing to do with Wi-Fi. That's outside the scope. That's a multicast thing regardless. Wi-Fi just is a place where we don't get that transmission acknowledgement. The point that came out to me that I was not prepared for at all in that conversation was power. We had people from Google there with the phone. We had people with Apple there with the phone. All of them were said, no, this just is sucking our battery life down. And it wasn't because of multicast. It was because the applications that used multicast. So it's kind of like we have two-tiered problems here. We have just the lossy problem with lack of retransmission. And then we have the way the applications have to just always be listening to stuff and staying alive and killing the battery life. So unfortunately, we don't have that representation here of those people who are in that list. But that's the kind of intelligence we need to bring to this document and kind of separate, I think, the problems into those two spaces. Go ahead, one more.
Rick Taylor. There's some crossover here with some of the work that Mane has recharted to do. So Mane's got a charter item to look at multicast frameworks for meshing radio systems, more general than 802.11, but everyone's using 802.11 as because you can buy them rather than complicated kit. I'm not sure how much traction that is getting in Mane, and I would suggest that you guys seem to be better organized about this. It's good to see Charlie Perkins' name on there because he's got a foot in both camps. So I would be tempted to reach out to the Mane guys and say, hey, we're happy to take ownership of this, concentrating on 802.11 to start with, and that might solve some of the problems on more general radio systems.
Or come help us.
I might well.
Thank you. All right. Anything else? Thanks, Mike.
Can you ask for a call? Working group.
Okay. Thank you. Who thinks this is work that the working group should adopt? Raise a show of hands if you support it. All right. Who thinks we should kick it to the curb? All right. We'll take it to the list.
Thank you.
Thank you. Next is.
I'm not Tim, but
You're not Tim.
I'm not Tim. So if someone in the Jabber room can take over my Jabber scribe duties for this for the duration.
Is there someone in the Jabber room right now?
There are people in the Jabber room, but I don't know
Okay.
if someone in here can.
Let's
Otherwise,
see, Jake's there. John. All right. Roll.
okay. Let's see here. I can just the mic. I'll just do it like this instead. Great. Okay. So either standing, looking there, or looking down. Okay. So this draft started about I think models describing different ways of doing multicast, and we were giving feedback to bring down the description of the models and focus on deprecating interdomain ASM. So this was this 2 or 3 IETFs ago? I was here and said, where's the document that says don't do ASM with interdomain? Everybody knew it, but there was no document.
That was actually 2004 from Lenny and I, but yeah, I kind of.
Okay, but I was kind of like bringing it up probably. This is so Tim had a whirl at this document and changed part of it due to that feedback. But it's still, at least for me and for a lot of others, what does it mean to say we deprecate something? So this is, we don't know if this is the right way of doing it. I think we all know what we want to do, but like what IETF speak do you use in order to say what we want to say? Yeah, next slide, please. So this comes from simplifying operational practices. I've personally myself done interdomain ASM. It broke every 2 years, and yeah, it's just fragile. And it seems I'm not the only one. So yeah, more people want to deprecate it, and I guess tell people don't do this if you can avoid it. And it's like, yes, MSDP is still needed for Anycast RP. So why not want to deprecate MSDP by itself? Okay, next, yeah. So Tim cut down some of the text on the models, and he did a new section. We're talking about these different parts of what mechanisms are used for ASM, for SSM, and so on, and describe that, and also a way of supporting an ASM application so that it actually does an SSM join from the edge. If this is a way of supporting older applications, for instance, linear TV. Next slide. So this is also about, I mean, we don't say never do it or it's now forbidden or something like that, but this is a recommendation document. And this whole IPv6 about embedded RP, should we do the same thing with that, or is that still okay? Yeah. And we do think that talking about, I think the general thing here is don't touch MSDP status or anything, just because that it's people still use it. And then talk about IGMP and MLD and what you need here in order to support the SSM join, so that people actually. So I've heard someone mention that they mandated IGMP version 3, but the application still did a start comma G join. So just you actually needed to say you need to do an S comma G join, and it's not about the protocol version. Okay, next slide.
We take my question.
Mike, Stig.
Okay, Stig Venas. Yeah, I'm not sure if I should mention this now, but I don't feel like deprecating embedded RP myself, at least. It has some, it works better, lots better than, you know, using MSDP and all of that. And we don't have much experience with it yet, so might just, you know, wait.
Do people actually use it?
Yeah,
they do.
I would think though. I mean, I don't know how much it is used on the internet or the Mboned, whatever. But there are cases where people have peerings between domains and they use it just between a couple.
But I think that if we're saying don't do ASM, it says both for V4 and V6. I think the general advice is Next slide. And it's like this is the same I think to a lot of other of these mechanisms. It's like we don't tell people, you know, filter it, you cannot do it, blah blah blah. So that's, I think what we want to do is have a strong recommendation and back it up by advice. I think, I don't know if that there is anyone who wants to do anything else, but yeah, that would be good to hear. So this is also about for application developers, because I think that if you come in, you want to develop a new application, the whole thing about having ASM and do a start comma G joins might seem great, but they don't understand the implications of doing that at scale, because if you're just looking at it from the edge, you might get a different idea.
So let me throw a question out there. Just Greg Shepard, contributor here. It's nice to think that application vendors will look at this for guidance. When have they ever? I mean, it's tragedy of the IETF, right? I mean, we have people who just randomly pull Class D addresses out of their tail and embed them in devices without any concept of how it's going to impact the network or direction from the IETF. So this is kind of a question above the layer. I support the work here, but how do we make this work actually do anything?
Yeah. So at least I think it would help me in some of my historic struggles against application vendors that only did start comma G joins. So say, look here, you know, well, I don't want to do this.
So those of us who do interact with the operators, or excuse me, the application developers, can at least have a weapon to beat them over the head with. Fair enough.
I mean, I'd rather have that than not have
no
that.
stick. Yeah, exactly.
I mean,
all right, so
it's not going to revolutionize the world, but at least it's one more stick. Yes.
One more stick.
Yes.
Fair enough.
And I mean, it's also when someone comes along and says, "Oh, why should I make my application more complicated by using the source by having a side channel for source discovery?" Like, I need my applications to discover what source.
Yeah, so we can go off and over in this conversation. We need to speed this up along. But that conversation happens all the time.
Yep. And
the answer is always the same. How'd you learn about the group? How'd you learn about the port? How'd you learn about the encoding? I mean, all that's out of band. We're just asking them for one more field in the same channel.
Yeah, right. Okay, next slide. Right. So, okay. I guess what we're saying is there's a new revision. Comments on where we're going, is this the right way? I think if we want to speed it along, that's basically what we're saying.
Thomas Eckert. Yeah, sorry, I haven't gotten around to more than quickly browsing through it yet, but it seems that maybe do we want to be honest in saying what gaps we may still have with SSM, or, you know, the things that people run into that are actually SSM specific, like source redundancy, right? That, you know, we can give recommendations here or, you know, punt the problem to another document, but maybe be honestly saying, you know, also the problems that.
No, I think we're adding too much to a given draft. What we're talking about is just trying to give direction ASM versus SSM deprecation. If you want to talk specifically about challenges with SSM, that should go somewhere else.
Okay,
Otherwise,
but
we'll just keep
then
layering this.
how would people, you know, rightfully want to adopt something when they see that, you know, somebody says, don't do the stuff that works, do the new stuff where I, as a, you know, user don't know how it works. Like, I have no idea how to do source redundancy. I'm just playing
Source
devil's
redundancy is not specific to the SSM architecture. That's an
It is-
operational consideration that can be documented separately.
No, I mean, it's
yes.
basically, it's a problem that you need to solve differently in SSM than ASM.
Stigmanas, I think the document is great right now, and I think it should be adopted.
Right.
It's really easy to read and lots
So
of
who's
text.
read the draft? Who thinks this should be adopted as a working group item? Okay, not all the readers. Who thinks should be kicked to the curb then? All right, we got support. We'll take that to the list. One more question.
No, just a comment to the source redundancy. I think it's important because we did the move from ASM to SSM and with the mapping at the edges, and we had to fix the redundancy for the application inside the network. So I think it's important.
Oh yeah, I agree it's important. The question is that really part of this intent of the document? All right, next then. I got to move this thing along. Thank you very much. Thanks, Tim. Now it's this guy named Eckert. Have you seen him? Eckert? Anyone? Let's try to be quick. Sorry.
Yep. Okay, something for your, you know, sleepless nights to read up. So after Prague, we basically did some few changes to the document. Then it went to IESG review, and we got a humongous amount of discusses back. At which point in time, I started to move it over into XML and GitHub so that it can easier be added and also hopefully, you know, come out through RFC editor. And then I started doing the changes listed in the following slides. Next slide. So that's the diff up there. There were a bunch of small things. I mean, most of the stuff really came from a lot of the feedback from all the reviewers on the first slide. Next slide. So more pictures. Right now, each of the scenarios that we have has a nice ASCII picture, and the tunnels are obviously differentiated from the physical peering point. Next slide. There is now obviously a section about congestion control because that's part of the standard IESG review, and there's also pointing to BCP 145 that, you know, just came out last year, which has all the multicast congestion control. Put an example, kind of what's the worst typical case, what happens, right? You have something that's controlled multicast, inelastic, you're sending it to another AD, which autonomic domain where it's, you know, in best effort and everything goes down. So that's exactly what you want to avoid. The receiver rate adaptation, and finally the also the challenge that when you're using receiver rate adaptation, you typically have a lot more dynamic S, G state. So you need to look at the performance of your forwarding plane. Next slide. Public peering. Added a section because there were kind of you know, on and off references to if it's not a private peering. So I described the problem. You know, you have a LAN between more than two ASs. You're running a multicast over it, and you're running into all these wonderful problems with PIM assert. Described the three possible solution cases. The management interactions. So I tried to introduce a clear description of what really, you know, IESG always comes back with ultimately what ends up to be about privacy. What are you revealing about the customer? And so the model that we're adopting here in the draft is that ultimately the AS1, which has the multicast source, is one that is also responsible for your content relationship, meaning that the fact that it knows about your multicast traffic is just a small subset of what it knows about you from, you know, being the content source. That way, you know, the problem is pushed back. Next slide. Troubleshooting, mtrace, traceroute. Yeah, the one thing that basically I had to add there is that the most important troubleshooting tool, mtrace, doesn't work through AMT tunnel. So that might be actually something of interest for us to, or PIM, to fix, because that really is bad. Then they said we need to rewrite the security considerations section. So now there's a long security consideration stuff. One big bullet point is DOS attacks. So that's kind of creating state or pulling in too much traffic, describing these problems and how they can be solved. Next slide. The content security, so that's discussing the alternative, free-to-air content versus content that has DRM, and then the main challenge that we've seen in service providers that are deploying intra-domain, for example, traffic filtering for the multicast traffic, so that even though it's encrypted, you can't even get a copy, which you could easily decrypt if somebody else has cracked the key for you. So that's done intra-domain, and if we want to do the same thing inter-domain, then the problem is a little bit of knowing on both sides what the S, Gs are that are carrying traffic. So that's kind of a management issue between the two ASs in that case. Peering encryption, details about the operational aspects. They're also talking about how the exchange of out-of-band information, like the S, G states, program channel information, how that can be encrypted. But for example, just passing it through the peering point. So those were explicit asked by the IESG to comment on those operational challenges. Next slide. So of course, there can be no document today anymore without privacy considerations, and the privacy consideration in this case, I think for interdomain multicast peering are fairly small. So the main challenge really is AS2, who didn't have a content relationship with you, can see what S, Gs you're receiving, and from that they can deduce to a good degree, what content you're consuming, and that is the whole extent of change of privacy. And yeah, you may want to use the one model where you're AMT tunneling across AS2 if you have any content where you don't like that. And yeah, so it's basically, what is it, on Sunday, Alicia did approve it, so it's now in the RFC editor queue.
That was you and the status. I was applauding both you and the status. Okay, good. Of course you're applauding me. Of course. Thanks, Orlis. And we got Zhang. Looks like they spelled your name incorrectly on this one. Right? You got the next two presentations? Screen.
Good morning, everyone. I'm Sandy Zhang from ZTE. This presentation is for multicast information model. Next. The first page is still the motivation of this draft. We want to stand a high level to leverage the existed separately multicast model to control the multicast network. Next, please. And the second is still the content of this draft. We provide a human readability of the whole multicast network by UML class diagram. And also we provide a young model for the technology. So you can use it directly and you can diagnose your network by it directly. Next, please. And the update of this version, we add overlay technology in the UML diagram as has been missed in previous version. And also we add BRTE in multicast transport layer. And also we make some revision to the model. And I'd like to say this model has been verified in Open Daylight BR project. And the project has been released in Carbon version. So this young model is feasible and practicable. Next, please. This page is a brief introduction of Open Daylight. From it, you can see that Open Daylight project is driven by several models. Next, please. So this is the BR project information in Open Daylight. From it, we know that the project is driven by two young models. One is the multicast information defined here, and the other is BR young model defined in BR working group. Next, please. So it's a detailed update of the diagram. In the overlay layer, we add the overlay part of this has been missed in previous slide, previous version. And also in transport, we add BRTE next. The data model overview is remain unchanged. It still be comprised by 3 levels: overlay, transport, and underlay. And the multicast information is still the key of the Yang model. It remain unchanged. And in overlay layer, we add BGP and MLD snooping in the overlay technology. Next, please. And also in transport, we add BRTE as one of the part of the transport technology. Next. And in underlay, we add Babel as one of the underlay protocol, routing protocol for the multicast. Next. So this draft has been printed for several times, and we'd like to know where is the draft should go. So we'd like to call for working group adoption. And also, many thanks to Stig and Jake for their valuable comments and suggestions. Thanks. That's all. May I call for working group adoption?
Question?
Beg your pardon. Rick Taylor. It's a sort of Yang-based question. I was sat in one of the, I think it's routing area meeting first thing yesterday, where they were introducing the schema mount points. It occurs to me that when you've got your underlay specific, I can't remember the exact words, but your underlay points for BGP or Babel or whatever. Yeah, that slide. Would that be a good candidate to actually have a schema mount point so you wouldn't have to specify a particular node for each of those types of routing protocol? You could explicitly say there's a mount point for your routing protocol specific bits and leave that bit of the Yang model to the relevant area, meaning less work for you. Just a question, are you following that work, the mount point, schema mount?
Do you mean that we can add more detail about how to use the underlay protocol to deploy the multicast?
Yeah.
Right? Maybe I should add more detail about it, because in OSPF or ECS, we know that it's the underlay protocol of BEER. BEER is one of the multicast technology. And also BGP is under discussion for the multicast delivery, information delivery. And also PIM as original the technology. So it has been here. It must be here. So the Babel is the newest underlay protocol to deploy in HomeNet or other slow network. So yes, I can add more detail about it.
I may not have explained myself well. My question is about, for each of these nodes here, so Babel or BGP or OSPF, the information underneath, is that specific multicast underlay information?
Yeah.
So it doesn't include general purpose BGP information?
Yes. It's only core, when we deploy it, when we decide to use the OSPF as one of the underlay, it will invoke OSPF technology to do the underlay network. And also we do not define the detail of the OSPF detail. We only send some information about our multicast service.
Yeah. Okay, so I still think it's worth you looking at schema mount, so that because I know over previous IETFs, I've seen you present in most of these routing groups to say, BEER extension for Babel, BEER extension for BGP, or, it's available for PIM, etc. Maybe you can do a cleverer thing with your Yang model by using a mount point here. Just perhaps you should talk to the NetMod guys about, I think it might simplify your model and mean a lot less churn.
So can I interject here just a question? So are you working with a Yang doctor on this so we can guide you through?
No, it haven't not been adopted as a working group project. So no doctor will review it. But
really? We have to adopt before they actually review? Wow.
Yeah.
That seems
I think
bizarre.
young doctor haven't so much time to look for all the private draft. Yeah.
I think you can ask, surely.
Yeah, we get some AD input here. That'd be
Yeah.
great.
So I don't know definitively, but I'm sure that we can ask them and say, we're strongly considering adopting this. It would be really useful for the young doctors to look at this.
Okay.
I'm sure we can make that happen. I won't swear to it.
I
in
can
case
send
Ben
it
wants.
to the young doctor mailing list.
Could you
Right.
reach out to Sandy on your issue about the point? Yeah, because and at least point it to the people who are actually working on this to consolidate and simplify.
I think I'd start with Benoit. I mean,
Benoit?
yeah, I'm not a huge Yang expert. I'm not
Right,
a
but
Yang
he is-
doctor.
yeah.
But for whenever I see things like this, I always start with Benoit, and he points me at the right person.
Excellent. Thank you. All right. So this is the kind of direction this group's got to start providing anyway. I mean, clearly at some point we have to adopt this work. If not this, something like this, and we've got energy and traction. So some sense of the room, who's read it, pieces of it, versions of it. Okay. Who believes we should adopt this work for the group? All right. Who thinks we should kick this to the curb? It's not our
So
responsibility.
Jake Holland said adopt as well, and he said even if we adopt it, we can run it through the Yang doctors and then revise it. If we need
Yeah,
to.
right. Like I said, this work has to take place somewhere anyway. I think there's nowhere else we're going to find multicast people in the IETF consolidated in the scale we've got here. This is where this work should take place. And like I said, even if it doesn't go off like this, it will evolve with some support from the Yang community, and we'll have something that we can publish. All right. Next. You're next. Aren't you next? No, the difference next. Jeff, how you doing, man? Yeah, go for it. Yes. Oh, I'm sorry. Yeah, yes, we had general support of the room. Thank you. I was leaving them guessing.
Hello? Okay.
All right, go ahead, Jeff.
All right. So this presentation is about MVPN source active routes and MSDP source active messaging interoperation. This draft, I think, is going to be homed in the BEST working group. I'm also going to have a presentation there. But this Mboned has the MSDP work before.
Yeah, stay on the
so
line.
yeah. I'm on to present here as well. So the first slide is about a very brief review on how MSDP works. In this diagram, we have 6 RPs, ignored other routers, just RPs here. There is a first hop router on the upper right corner sending the PIM register messages towards RP1. And then RP1 will send MSDP SA messages throughout the network to other peers. On the lower right corner, we have a last hop router sending a StarG join, and it arrives at RP6, and then it stops there. And once the RP6 receives the MSDP SA message from RP1, it will then send the SG join, PIM SG join towards the first hop router. So that's basically how the MSDP works in very high level. Notice that we need to have continuous MSDP sessions among all the RPs so that they can learn the sources and then they can send SG joins once they have the corresponding StarG join.
No, I get slide. You just
Okay,
gotta
next
put it.
slide.
Sorry.
So MVPN source active is very similar. Here I have those 4 PEs. I have a customer RP in the upper middle of the diagram, and I have a CE router at the bottom. Again, I have first hop router sending SG joins towards the customer RP at the top. And that customer RP has a MSDP session with PE1. And because of once the PE1 learns that source through the MSDP SA message, you will send the MVPN source active in, and that will all be received. That will be received by all the 4 PEs. And notice that here the CE is not a CRP here. The CE device gets that is connected to PE3. It gets a StarG join from NASHOP router. It will continue to send StarG join towards the towards the PE3, because PE3 is the CE's upstream router towards that customer RP. Here, the PE3 has the StarG states, and also has it learns the source because of the MVPN SA routes. Then it will send MVPN join, which is a basic MVPN semantics routes towards the PE2, which is the UMH router, upstream router for this particular source. So you can see that the MVPN source active routes and MSDP source active routes are very similar. Here, the PEs are just like the RPs, and also so now there's one caveat, one exception between the when it comes to the similarity between these two, MVPN and MSDP. Next slide. So a PE, it will advertise MVPN SA when it learns the source through the MSDP SA messages, but it will not do the opposite direction. So when it receives the MVPN SA routes, it will not convert it into MSDP SA routes. So in this example, imagine that the C at the bottom, instead of a regular CE, we have a custom RP2 there. And then PE3 and CRP2, there between the PE3 and CRP2, there is an MSDP session there. Because that CRP2 there, it will terminate the StarG join there. It will not send the StarG join, pin join towards the PE3 anymore. So PE3 will not learn the source through the MVPN SA routes, but it does not learn the StarG join. And PE3 does not advertise MSDP SA towards the CRP2. And as a result, CRP2 does not learn the source, and PE3 does not learn the StarG join. So here, then nobody will send this SG join anymore. This, I believe this is just pure oversight in the MVPN protocol. It's not specified there. Now, because of that, then we need to have a MSDP session either between PE1 or PE3, so that we can have a continuous MSDP session from CRP1 all the way towards CRP2, or we can have MSDP session between PE1 and CRP2, or between CRP1 and PE3. Once you have that, then you have the continuous MSDP session, then things will work.
One question about the Anycast RP PIM extension, the stuff that we should be using instead of MSDP. What's the situation in that case?
So in this situation, the MVPN only has the only relies on the let me see. You're right. That's the P1. If P1 advertise use Anycast CRP to get a PIM register message from CRP1, then it would work the same. But again, when it comes to P3, P3 would not would need to learn the SG register from P1, and then it will send SG register towards CRP2 there. It's very similar. You need to have those continuous.
Yeah. So obviously, if the problem exists there as well, that should be what we would be primarily concerned with, and sure, fix it for MSDP as well. I hadn't, remembered all these MVPN specs that, whenever we're writing something about MSDP, I'm mostly worried about what status the resulting RFC has, right? kind of we can really write something standards track mentioning MSDP, right? So if that was done with the MVPN RFC, that good luck, because usually, you know, it shouldn't be more than experimental. But that's just IETF process for the poor working group chair. Other than that, yeah, let's make sure that it's fixed as well for the Anycast RP.
Yeah, sure. Okay.
Thanks, Troy. That's good input. More?
Next slide.
Yep.
So solution here, at least in the MSDB case, is simple. We basically specify that when the P3 gets the MVP assay, and it will treat it as if it's received the MSDP assay messages, then so that it will advertise the MSDP assay towards the CRP2. Once that happens, you can see that the CRP2 now learns the sources, and it has a strategy join, then it will send PMSG join towards P3, and everything will start work. In addition to that, today the MVP assay routes does not carry the RP information, so we need to add that to the message using the extended community, so that when P1 sends the MVP assay routes, it will also carry the CRP1's address there, so that P3 will be able to propagate that towards CRP2. Next slide. So yeah, so in this working group, at least previously we were talking about deprecating MSDB. Well, that at least has been clarified that it's not really about deprecating MSDB, it's about deprecating the interdomain ASM. But on the other hand, MSDB is actually widely used for interdomain as well for some customers. So this is really about some real deployment scenarios that customer has between their MVPN and their MSDB infrastructure.
Yeah, so to answer my own concern about the status of this thing, right? I think if we declare this as an update to the MVPN RFCs, then I think we can most easily inherit whatever status they have.
Yeah.
You know, updates, foobar, whatever the number was, 6150 or something.
Yeah.
All right, so who's read the draft? All right. Who think this is work that that our group should adopt in some form? We have comments. Good, thanks, Stig.
Stigvanas, so I see the name of the draft is like BESS, and are you intending to get this adopted in BESS, or you are happy to do it here, or what's your thought about that?
Okay, to clarify that, I think we're going to seek in the adoption in the BESS working group, because this is about it's really about MVPN procedure.
Yeah.
But this obviously this working group will need to be involved.
Right. Yeah, that was my thinking. I think it might belong more in BESS, but it's great if people here are involved. And I guess one question I had too is it a common problem with customers that they face this, or is that problem to move the RPs to the PE or instead to kind of solve this problem? Or at least that's something this group would know maybe more about the deployment challenges.
It's actually a quite common problem. We got quite a few customers running into this situation. Actually, can you go back to one of the slides earlier? Continue.
Keep going.
Yeah. Okay. Okay. All right. So here, because of this oversight today, the customers have to have the MSDB sessions between PE1 and PE3 or some other way. But notice that those sessions will be the per VPN sessions. And also because with those additional sessions, so now let's say the PE1 advertise MSDB assay towards PE3. And then when PE3 gets the assay, you will also advertise MVPN assays into the network. Now, so both PE1 and PE3 will advertise MVPN assay into MVPN domain for the same source. It becomes very excessive in certain situations. So it's very clear, at least to the situations that we have run into. This the workarounds is not ideal. It's not desired.
I'm not sure, but maybe the question was this deployment scenario, right? That you both have non-PE RPs and the PE RPs, right? And if I understand it right, then the PE RPs, the reason is because the service provider wants to run MVPN in a particular way that requires that. And then the enterprise customer already has their own RPs. Et voila, that's what you get here, right?
Right. Indeed. Can you go back to one more slide? So here, this is MVPN source active routes that is similar to MSBSA. That is for a particular MVPN mode. It's called intersite source tree owning mode.
No, the two RFCs, were they from BES? That you're
Yes.
mentioning?
Yes.
So then it should be in BES so that we can most easily declare it to be an update to that stuff. Yeah.
Right. Yeah.
Stigvanas. Yes, I think this is useful and I support adoption in BES.
Pardon me,
you.
can you say that again?
I think this is useful and I would support adoption in the
All
BES working group.
When is the
Thank
best working group?
Friday.
Friday?
Yeah.
Ouch. How many people are staying through Friday can help get some input? All right, thanks.
Okay,
Are you going to
thanks.
be here on
Yeah.
Friday, Rebecca? Okay, thanks, Jeff. One more question.
I'm relaying Jake Holland. Is this one of the situations where source discovery at the application level is impractical? Is more information about the details of the deployment use case available?
That can be made available. It's really it's really for the customers intra-domain situations. It's basically the anycast RP.
Intra-domain.
Yeah, intra-domain. Yeah.
All right. Any other questions? Beautiful. Thank you. And back to administrative stuff. So we just get some status of our active working groups. We got MTrace V2 has actually been submitted to ISG, and Intermain Peering now is in the editor's queue. Lots to discuss. Towards address the revs. It's our responsibility at this point to please read and confirm. I went through a working group last call, I understand, but revs are happening while it's in the queue, and it's our responsibility to keep on top of this stuff and make sure the document represents consensus going through in the room. All right. Other docs, we have info model, we have the Wi-Fi doc, we talked about a bit. And I guess Tim's going to give us some input, which we got through a proxy, Tim. But thank you. Read and respond to the list. We'll take the votes that we had today in the room as for adoption. We'll take those to the list to confirm. So please pay attention. I try to do this right after the meeting while people are still engaged, and hopefully before the holiday, because I know we disengage here in a few weeks and vanish. But thanks for your time. And it is now the PIM working group. Blue sheets for Mboned. Have they been signed? Everyone signed the blue sheet for Mboned? This guy over here, nothing but trouble. Where'd it go? We have one signer PIM. Where'd the blue go? Who's got it? Oh. No blue sheet for Mboned? You sit in a chair somewhere? Did your dog eat it? There. All right. Everyone signed it. Excellent. Oh, wait, one more signer. That's the PIM. That's going off next. Wait till those guys take over. I'm not doing their job.
No, just he said that. I was like, no. There's no. Yeah. Yeah. But there are dead applications. Yeah, that's true.
And we can pass around both. Yeah. Pass them back there.
Take it away, Tim.
Thank you. Good job. Well done. Do you have that? Is that the MOD list? Okay. Oh, yeah. Okay.
here's the pin list right here.
Cool. We started doing this now. Oh, that could be a problem. I can plug it straight into my laptop. Yeah. Slow signal so much.
Oh, because it's not on. So, hopefully it becomes a little something. Oh, there you go. Okay, cool.
No, I think it's a different Jabber room. Probably. Yeah, I think so. Thanks. All right, welcome to PIM. So we got a Jabber scribe already. Seems thanks for that, and I'll take the notes for PIM myself. It is? Oh, okay. All right. I see. Oh, okay. Thanks. I didn't know. Guess I can start sort of. So yeah, welcome to PIM, and hope you all have seen this note well before. If not, please read it or look it up. It's the same for all IETF sessions or working groups. This is our agenda. Any comments on the agenda? So we'll go through the working group status first, and then we'll have these presentations afterwards. Oh yeah, I do.
Oh, no, I got it.
All right, so we already in March we requested we requested publication of the PIM Young models. They've been kind of waiting in the publication queue a bit. Then the routing area decided to make changes for all the routing area models to support NMDA, which is some way of, I think, separating like intended and actual configuration state. And all the multicast Young models are being updated to also support that. Yeah, we have a so that draft was updated. It's still in the publication queue. It will go to IETF last call at some point. Yeah, if you like, please read the draft, and if you have any, if you find any issues in the draft, it's not too late to change it yet, but hopefully it will be too late soon. We also have this source discovery BSR that we requested publication for, I think, a couple of months back. So waiting for that to proceed. Explicit tracking, I think, hasn't had any work recently. I don't remember, but we would like to see some progress with the explicit tracking draft. If you want, or it's up, yeah. If you want to, sure. We have the offer here.
Oh, sorry for just late to update the progress. But actually, well, the comment from AD was to make it more suitable as experimental documents. So we are now inviting the vendors' input and just waiting for the update. So,
Okay.
well, we will update.
Yeah. Okay. Great. Thanks. Oh yeah, I am taking notes. I guess I need to remember that.
You got it?
I'm taking notes. Yeah. 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 Okay. You want to continue? I'll write something down here.
Okay, so the multiple upstreams draft, we are waiting for a revised version. It did pass working group last call. And I think once we have that revised version, we'll be able to take it to the IESG and then see where it goes from there. DR load balancing draft, that last draft listed there, it will be presented this meeting. It's been a couple years since we've had a working group last call, and we will likely be issuing another one shortly after this meeting. DR improvements will be presented this morning, as will IGNP MLDB Yang. It did pass working group last call. And as far as IGNP MLD Yang, being that it passed working group last call, what are we waiting for? Anything?
Not really. It passed last call just a couple of weeks ago. So just been waiting for the authors to state whether there's IPR on the draft, and I guess if you like, I might be the shepherd, so I need to do the write-up. But so it's basically done. That will also go to IETF last call at some point in time, though. And if you're interested, please read it. It's still not too late if you have any comments or issues on the draft.
Okay. All right, thanks. So we can talk a little bit more about that when it's being presented. And MSTP Yang needs to be reviewed. We feel that it's probably ready for working group last call. Is that one being presented this morning or no?
No. So yeah, so the draft hasn't really changed for a year or so. I think as far as I know, the design team is happy with the document. I wonder if it has been updated to support the NMDA models. I'm not sure. That's something to check. But yeah, so we have had all these young models we have here. They have been done by this design team with people from multiple vendors. So there's a fair amount of support, but we need other people in the working group to also have a look at the models. But given that the design team, is kind of happy with it, at least we need to get additional review of the MSTP draft. And it's great if you guys would just go ahead and review it, but I feel sometimes we need to do a working group last call to get people to actually review the drafts. Yeah, I guess that's about it.
Okay. And there's a handful of people in this working group that's working on Yang models. We thank you and ask that you continue to participate. So this last one, V4 prefix over V6, it was adopted after last meeting, and it'll be presented today. Yeah, so we can talk a little bit more about that. Okay. Okay, so why don't we get right to it then? If there's no comments about any of that, Ashutosh, let's give it a go.
By the way, I just want to say I have a hard time always saying NMDA or what it's called for these young models, because for multicast we used to talk about NBMA.
Hi, I'm Ashutosh from Abhi Networks. So this draft was first time presented in IETF 98, where, next slide please. We basically are trying to solve a specific problem, next slide, where you could have IPv6 unicast prefixes distributed using IPv4 sessions or vice versa, and this is using RFC 5549, and if you want to deploy multicast with it, we have a peculiar problem where you cannot actually identify your PIM upstream neighbor if you have more than one neighbors on that interface. So we had couple of, in fact, we suggested 3 solutions in first draft, and then working group here we discussed, and seems like that we wanted to have only one solution, and that's why the next draft was presented in last meeting, 99, where we, next slide, please. Next slide. Where we basically zeroed on this IPv6, PIM secondary list option, and that's what presented, and then later on approved, accepted by the working group. This draft, in this revision, we have slightly changed the model, the overall, I would say, we have just rewritten the draft in the way that we want to use, we are portraying the use cases for secondary list option. Whereas the RFC 4601 says that the secondary list addresses should be as in the same address family as primary address, but we have probably use cases where it could be of different address family, and one of such use cases is when we use PIM with RFC 5549, and this is how the new draft is written. That's it's one of the changes we have done in this version, and it's a quick update, and we would like feedback and this draft from chairs and the team.
Yeah, should add that I'm one of the authors, but yeah, I'm wondering if people agree with the current idea about basically saying you might deviate from using the same address family and just having use cases. I remember Torles last time said something about, you know, that this might be useful for other things, maybe also listing IPv6 addresses for IPv4. Let's see. Not sure now. And anyway, so at least right now we have like a single use case for why we might use this address list option for a different address family. And I think if the working group has any, see other use cases, we could consider adding those to the document as well. Or maybe talk about how it can be useful for transition or something. But there's one use case in the draft right now.
So anything else you need from the working group? Do you need more participation? Or you guys
Yeah.
got it, or?
If there is another use case people can think about, I think that's how Stig and I wanted to put it out. I mean, we know one. I think what Turles last time said that the networks which are basically transitioning over to IPv6, how we could connect IPv4 networks using IPv6. I think on something on those lines. And I'm not sure if this use case could be applicable here, but yeah, we could explore those options basically.
Yeah, so I guess our question to the working group is the working group happy with what they have now, and are we more or less done, or does the working group want to add more use cases, or is the draft just wrong and it needs significant work? I don't know.
Yeah, well, we adopted it, so it must be decent.
Okay.
Okay.
Thanks.
Thank you.
You don't want to ask what, but if it's ready for us, course.
I think so. Yeah, I think so. All right. Yeah. So from working group chairs, please review the draft. If you do have a use case per the request that may want included, then please do so. It was mentioned that Turles made a comment about a use case. Maybe Turles, if you can remember that, maybe you can contribute it. Yeah.
Check the minutes from last.
Yeah, maybe. Yeah, exactly. Okay, so Mankamana, am I saying that right? Did I say it? Okay, very good.
Good morning, Mankamana Mishra from Cisco Systems.
and I'll be going through PIMDR load balancing draft.
He'll come up in a minute.
Okay.
We'll take a little-
So what all things I'm going to cover, basically, I just wanted to give brief history about this draft because it has been around for quite long. And last time, I think Stig did speak to other chairs, and we decided that since it has been quite long for out of, so it was not updated for quite long, and people might not be still remembering what problem exactly we are solving. So we wanted to go through what problem we are going to solve and what all the kind of changes we are doing next. So this draft was initially presented in IETF 82, and after that there were multiple iteration, and it got adopted by 83, and in 2014 I think it went for AD review, and there was a couple of comments, and author most probably they got busy and they never updated after that, and we basically in the current draft we are addressing all those AD's comment.
If I can comment on that. So we did have last call and we requested publication of the draft as well. But then Alia, that was the AD at that time, she had some comments, and the authors never managed to update the document. And now we spoke to Alvaro about this, our current AD, and he basically said that it's been so long, so it makes sense to take it back to the working group and see if everyone are still okay with it.
So the problem statement, if you see here, so basically what exactly we are going to solve. So there with current, if you see PIM protocol itself has been deployed widely, and it's being used. So definitely question comes that what exactly is the problem here which we are trying to solve. So in this picture, if we have 3 routers, R1, R2, R3 in same LAN segment, and only one of them is going to be PIMDR as per our RFC 4601. And what we are not doing is we are not sharing the load between multiple routers. Can we go next? So in this topology, what I am showing that there is a GIGI link towards switch from PIM routers. And this is one of the multicast flow. For example, I am taking that the current multicast flow is taking around 500 MB. Next. So we have one more request, which again, it is for 500 MB. And if third request comes, if you see the total throughput what R1 can provide, it's just 1 gig. Whereas we have a request for 1.5 gig. So basically what we are going to do, we are eventually going to drop 500 MB of the traffic. But in this whole LAN segment, there are 2 routers potentially which could be PIMDR. Why not to share the load? And the second problem, if you see, it's not only about load sharing. So in today's world, we are trying to do fast recovery as much as possible. So if we see, for example, if there are 1000 multicast flows which are flowing via R1, which is current PIMDR, and if there is any failure happening in R1, we are going to disturb the whole 1000 multicast flows, and they are going to shift to R2. So basically, we are going to relearn our core. So R2 will be joining the core tree, and multicast traffic will flow via R2. Next. So what exactly? So we are trying to solve these 2 problems in this draft. That the first thing was, if there are multiple PIM routers which can be DR, why can't we share the load? So in this solution, what exactly we are doing now with DR, we are having group DR. So basically DR election will happen per group. There are few groups which will be flowing via R1. There are few groups which will be flowing via R2. And so now if you see load is going to get shared between both of the routers. And the second problem which we talked about was failover scenarios. If you see here, if R1 fails, even though R2 is going to take over, but we are going to touch upon only those flows which were flowing via R1, and the flows which were flowing via R2 will have no impact. And which all places it is applicable, it is only for last hop router, because first hop router doesn't really make sense to do any such thing, and it is for SSM, SSM and DM mode only, and BIDAR is not scope of this draft. So this draft actually introduces a couple of protocol changes, but these protocol change is not between the version 5 and version 6. This protocol change had been there for from the day one. And what exactly we are going to do? So basically now router with their PIM hello, they will announce themselves as a probable DR, and PIM DR is going to elect the GDR. Basically, GDR is nothing but which all router could be potentially, they could become DR. And the PIM DR is going to provide list of GDRs to all of the PIM routers. And once any router, it knows that I am one of the GDR. So basically, when we get, can we go back? So when you get IGMP join, and if router is one of the GDR, basically it is going to do hash and see that if I am DR for this particular flow. And each of the GDR, they are going to run this hash per IGMP join and create forwarding states. And GDR assert, so there are transition time when basically when any GDR is moving from GDR to non-DR. At that time, it might happen that outgoing interface has not been removed right away. In that case, there could be assert, and in those cases, we would always like to consider that GDR state has to be considered for assert winner, because if we go only via IP address, it might so happen that the router which is going from GDR to non-DR wins the assert, and there will be traffic loss. Next. And so there were a couple of minor comments, and there is a section 6.2 where more of the comment were in the section 6.2 to add more content about how exactly DR, GDR will whichever router who is supporting this specification, how they are going to behave when they get IGMP join. So in this version 6, so basically version 6 of this draft, we have edited more of section 6.2, and there is a link which provides the complete list of comments from AD.
Were those comments from a couple years ago?
Yeah, it was from 2014.
So are they still necessary, do you think?
So some of them were necessary, which we have already edited. Some of them which I felt were not necessary, I have not taken care of. Yeah. That's
okay. So I guess no comments. So just a little bit of detail about the plan going forward. So when was this last updated? Very recently? So it's been about 6 months. Okay. So has anybody who's read this updated draft? So we have just a couple hands. Okay. Okay. So we've got a few hands. All right. So I guess the request from the chairs would be to have more participation in reading this draft. If you have comments, please ping the authors. Our intention is to, reissue a working group last call. So we just need to make sure that we're in agreement as a working group that that's the point that we're at. Does that sound fair? Okay. Any other comments, Dig? Are we good? All right, Sandy, you're up.
Good morning, everyone. I'm Sandy Zhang from ZTE. This presentation is for the updating of PIM-DR improvement draft. In this version, we have co-author Bankmana from Cisco. Thank Bankmana for his contribution to this draft. Next, please. The update from version 2 and version 3, we add more statements about capability with non-DR improvement capability router. And we add more statements about election algorithm. And we add a new section for applicability of standard side. Next. It's a supplement of a solution. When a new router which have no DR improvement capability comes in, the new router sends the hello packet with its DR priority at first. It's according to the FC 17761 and the older version of PIM protocol. After the new router receives hello packet from the existing DR, it compares the DR priority. If the new router elects itself to the DR, it sends hello packet with DR set to itself. So the existing DR will receive this packet and the existing DR will elect the new router to be DR according to DR election algorithm. So the algorithm has compatibility with the non-DR improvement capability router. So it can be used between non-DR improvement capability router and also the router has this capability. So we think this draft is stable, but we still think it needs more review. So please read this draft and give us some more comments about it. And after that, we think that it may ready for working group last call. Thanks.
So I'm curious, so many people have read the DR improvement draft just to get some idea, people actually are looking at it. There's maybe a couple of people. Yeah. But yeah, we definitely could need more people to look at this, and yeah, I'm planning to look more carefully at it myself as well. It's hard to make progress if we don't get people to review the drafts.
Okay.
Hello, good morning, everyone. I present the multicast Young design team to introduce the updating information for the IGMP and MLD Young model. Next. Okay. Last meeting, the IGMP and MLD Young model is the version 4 or 3. I can actually update the Young model draft had been reviewed by the working group chairs and the Young doctor, and according to the MD compatible version and some comments from the main list, and it has been passed to the validations. Next.
Can you remind us what NMDA, what is?
It has updated according to NMDA.
Yeah, can you just
Oh,
the mic?
okay.
Can you or somebody just describe to working group just high level what NMDA, what is it asking for Yang models to do? There's an update to Yang models, right? NMDA. What is NMDA? Does anybody? What is NMDA? What it is? What's its? Why are Yang models being asked to conform to NMDA? Like, what's the purpose of NMDA? Do you or anybody know? Yeah, thank you.
Okay.
Rick Taylor. And I'm not a Yang specialist, but from my understanding, the NMDA change is instead of having a single Yang model which has your configuration parameters and your running state all blended together in one tree, half of which is read-write, half of which is read-only, the NMDA, and I can't remember what the acronym stands for, splits that into two data stores. One is your configurable data and one is your ephemeral running data, but they've complicated it beyond that to add multiple data stores with multiple names, and then there was lots of arguing. But it's basically to do with the split of read-write config and running information read-only.
I can just quote from there is a draft. If you search for Yang and NMDA, it basically says, adds the ability to inspect the current operational values for configuration, allowing clients to use identical paths for retrieving the configured value and the operational value. So it's basically a way of figuring out, okay, I configured you to do this. What is your current state? Did you actually end up in that state because I said you were going there, or did you fail? So that's basically a way of, instead of having a separate operational, that could be different from the configuration way of doing the Yang model. So it's a way of simplifying and basically doing the operational, you get the operational values for free when you're doing the model.
Okay, very helpful. Thank you.
For this chapter, we merged the configuration and the operational state to the one. Okay. For the updating according to the NMDA version, we still have the three-level hierarchy, and the global level and the interface global and the interface specific level. So after the updating, every level has the configuration and the operational state, exclude the interface global. And the attribute for the IGMP and the MLD not changed, just the structure has changed. From the mailing list, we have the comments and the IGMP and MLD some features. One is two features we add to the Yang model. One feature is that the lightweight IGMP v3 or MLD v2 reference the RFC 5790. That means the simplified the exclude mode in the protocol for the standard. Another new features for the expliciting tracking, and that because some wonder specific implementation has the feature. So we add the new features for the configuration. We add two configuration in the interface level. That one is the explicit tracking enable, or and the exclude it for the lightweight IGMP v3 or MLD v2. So in the operational state, we add the host information about the host count and the list of host address and field mode for the explicit tracking function. So next is that we ask for the working group last call, or you have welcome to the more comments.
Yeah, so that the draft already passed working group last call. These changes were based on comments during the last call, right? So, so we are ready to publish this. But if you didn't read the draft during the last call, yeah, please go ahead and do so. I'm hoping there's no outstanding issues, but happy if people can help check. But at least, yeah, we had a design team behind this. They were happy with the draft, and then there were a few people responding for the last call saying it was fine, but making a couple of comments. But we could need more input. We figured it was sufficient to say the last work group last call passed, but we really would prefer more input from people. But yeah, if people have review it and find issues, it's still possible to make changes. Yeah.
Thank you. All right, so very good. So now we have a couple individual drafts, and Hongji, you're up. Yeah, thank you.
Good morning, everyone. My name is Hongji. I'm from Ericsson. Now, this IGMP smoothing young model, the effort is from the Monaco's the young design team. We hold a regular meeting on every Monday evening. Yes, that's it. This is the second version for the presentation. After the last meeting in IETF 99, we have reached a new agreement about the whole structure about the IGMP snooping. The IGMP snooping instance is defined to configure the parameters and show the operational state. It also follows the NMDA standard. Now this is the functional schema for the IGMP snooping instance. In this instance, the IGMP snooping instance could fit for both the bridge and the VPLS scenario, and that is determined by the value of the type. If the type is if the value is bridge, and this instance will be used in the bridge scenario. Okay. Name is the name is the key for the IGMP snooping instance. We also define the IGMP router instance, and the L2 multicast group, routing group could be configured manually. This is a static bridge MIME router interface and a static L2 multicast group. And all these attributes here are read and write. These are the read-only attributes. The attributes show the operational state data. There are three kinds of outgoing interface, which is a interface ref, L2AP instance AC ref, or L2AP instance PW ref. We have utilized the existing IETF interfaces and the IETF L2AP module to indicate the outgoing interface. For example, the L2AP instance PW ref, and this is it's a ref leaf ref for this L2AP instance endpoint and PW and the name. After we define the IGMP snooping instance, it could be referenced in the bridge scenario. It could be referenced under the bridge view or the VLAN view or the interface view. Generally, it should be referenced under the VLAN view. The L2 VPN scenario. The IGMP snooping instance could be referenced in the L2 VPN scenario. Actually, it is the VPLS scenario here. It could be referenced under the instance view or the endpoint view or under the AC or PW. We also define IGMP snooping RPC. It is used to specify the IGMP snooping cache tables here. the MMD snooping is the same as the IGMP snooping definition, except the IP address. One is IPv4 and the other is IPv6. Right, next. And now we have reached the agreement in the design team about the whole structure of the IGMP snooping Yang model. After I submit the latest version of the draft, I have got some comments from the mail list. And these are the unsolved problems. One is the attribute forward mode. The forward mode may be reconsidered because it's only fit for the instance, but it seems doesn't fit for the interface view. Next one is the comments from the Mohammed from the mail list, and this is the counter to the. He asked the counter to the non-member leave would also be useful. I have some confused about this question, so I would like to communicate with him on this meeting. Could you please explain more about this question? Wait.
So basically non-member leave, we wanted to count if router is getting IGMP leave for the group which it doesn't have join state. So it never received any join, but it is receiving leaves.
Actually, I have defined some parameters under the statistics. They are the pim hello and also includes the leave packets. I think it's just the leave packets, leave reports. I don't care if it is the non-member leave or member leave. I think.
So processing for both of them are different. If it is non-member leave, basically you are going to drop it, or maybe it depends on deployment or implementation, how it's being implemented. But yeah, if you think it's not necessary, then it's okay.
Oh, okay. Let me see after this meeting. Thank you. Oh, nice. Next off, is apply for the work group adoption and welcome more vendors and carriers involved. We also need more comments. That's all.
Yeah, thank you very much. So good job getting good representation across a variety of vendors. It's great to see. If you want to have more, then that's good as well. I guess we should probably ask working group adoption. Do you have any other comments before we do?
I have some comments, but we can ask about adoption.
Okay. All right. So I'm not going to even ask who has read the draft because very few of us do, unfortunately. But by a show of hands, yeah, exactly. Exactly. Yeah.
I mean, we do have tools that validate them. So, I mean, what we want to know ultimately is one, what's in them, which we've had a pretty good discussion of, and that they validate. Like those are like the primary considerations. And of course, do people find them useful? Yeah. Because if they're not useful, well, then the other two considerations don't matter very much.
Rick Taylor again. I sound like a Yang fanboy now, and I'm not really, but the Yang models are really important because people have got to be able to configure this stuff, and otherwise we're back writing MIBs again, and you need to kind of balance that. Somehow we got to model this stuff, so Yang is worth it, and I know it's hard and it's tedious, but it's worth it.
Michael Abrams, and yeah, I just want to reiterate that the way we do things, if there is no Yang model, we can't configure it because that's how we do things. So Either it's vendor proprietary models or it's the IETF models. We prefer IETF models because then it can be the same between vendors. So yes, I know it's tedious work and feels hard. I think it's hard, but we need it.
Yeah, I was going to add too. I mean, there's a lot of push for getting these models quickly through the IETF, and basically told, if the IETF doesn't do this quickly enough, then people will come up with their own models and not care about IETF models. So I think one question is, do you think it's useful to have a model for IGMP MLD snooping? And I think that the answer is fairly obvious. Yeah. And then, and I guess the next thing which is important, I guess, is for vendors to see, can they support this model? Does it include like leaves that it can't support? Or for operators, does it include the leaves you need to actually operate this box? So we need people that know multicast to kind of look if the CNA models have the right content.
Thomas Eckert. So the first thing I don't understand is whether or not it's permissible to have a Yang model as a standard for a feature that cannot be standard. So snooping, we had this wonderful political debate that it must be informational because snooping is so bad. And so we have an AD here. Is there an answer? Is that in the kind of downgrade or kind of, I don't understand all this politics, but it's just,
I mean, yeah, it seems a little weird, but I don't see why not, right? We've got the feature exists. This doesn't necessarily explain the feature. It just says, if you use this feature, which isn't really a standard, here's the standard way to do it. So yeah, it's kind of sketchy, but I think it's okay.
So you're saying there is no official policy for this?
I don't think there is.
Wow, Yang can do everything. I mean, no, but if I'm basically doing anything else that, a derived, protocol solution that somehow depends on IGMP snooping, everybody comes back to me and says that must be informational because you're depending on something that is an informational thing. And now kind of the operational interface is permitted to be standard. Sorry, I'm just pulling IETF process legs because I just, yeah. So. I mean, you folks come up with the standard answer to that, right? I mean, in the end, to me, it doesn't matter. I would agree with Michael that it must be, system model and whatever state it has, doesn't matter. It's just an IETF process. For you folks.
So, I mean, it's an interesting point. I don't think that there is I don't think this has necessarily been discussed before. I don't think that there's a written down anything, but I mean, we can always move it forward. And if it ends up being changed to informational, I don't think the track's that important as long as it's actually usable. But
yeah, I mean, mechanically, there's the question of downrefs, right? But downrefs are just a thing. We just do them, right? We don't view them as an insurmountable obstacle because sometimes we come along with a standards track document that refers to an informational document. Sometimes we even do that normatively. And that's actually just a thing that comes up in the last call, and we choose not to ignore it. And then when no one objects, we proceed. Or if there are objections, then we address them at that time.
Interesting that the question hasn't come up in before for Yang models. Okay. Yeah. So the other stuff then was in terms of we're still doing new features without having Yang models, right? So there were just a bunch on DR and stuff, which I think have configuration assigned with them. And so I was just wondering, is there any best current practice of, how many years can I wait with the Yang model, or kind of rather don't wait, but put the Yang model together in the same draft? Are any other working groups better than we are here in PIM?
So this works like with SNMP, but I think the Yang is now getting more traction. So I hope it'll be better. I mean, it's all about, is the IETF the right venue to do Yang model standardization? I would hope so. I'm not sure it is. I mean, it's all down to how do we do things. I would like the models to be developed here. I'm not sure the process is great for it, the way we do it with drafts, and because it takes years. There are a bunch of Yang models that have been, going through here for 3 years, not in this working group, but in for other areas. And if it's not done here, it's going to be done somewhere else. We need the Yang models. Either it's going to be vendor specific, or it's like open config. It's done in another SDO, or I don't know if you call it SDO, but I would like it to be done here.
Well, yeah, I was even thinking about, is it even possible with the way that these documents do one thing or the other to, let's say, no, sorry, you can't bring in the new bloody feature. It needs to be configured. The feature, RFC, the protocol RFC itself needs to have the Yang model. So that always avoids this, delay with the Yang model. And it's not possible.
Yeah, separate.
Yeah, but then basically you'll also, create these problems that they will come later.
So Warren Kamari again, just I realized we hadn't been doing that for the scribe. So, I mean, there is some work to try and make this less painful and move stuff faster. Benoit has a thing on semantic versioning so that, it's actually easier to do this and not have it be a many-year thing and then the RFC is published and then it's set in stone.
But I think that we've got sidetracked.
Yes, I do. But basically, I've had this happen where, we need to fix this. Then the vendor just goes in, does proprietary changes. We just take their model. And then hopefully a year or two later, out comes a standardized model that then all vendors can use. But this is like reality. That's the way it has to be. But I think all the working groups have to keep track of what stuff do we have that we don't have a model for and fix that.
Rick Taylor again, just following up from that point. There's also a reality that the people who are developing the best practices and the protocols are also probably the best people to define the data models. Even if they don't do it within the IETF, those are probably the same guys. So it kind of happens at the IETF, despite the pain involved.
Very good, thanks. And the good thing that gives comfort to Stig and I is that there are authors on these Yang model drafts that are working on Yang models across the IETF. So they know what they're doing.
Yeah, I also want to add that we have a design team that anyone can join. There's a wiki page. There's also a mailing list for the design team. And any of you, if you're interested, we would be happy to have more vendors or operators joining the effort. You're welcome to do so. And just ask me later, or if you want, I can send an email to the mailing list with just some update about where the mailing list and the wiki is and so on. Okay, so so maybe back to the initial question. We are wondering if we should adopt this document. So who's in favor of adopting this document right now? 2, 3, kind of 4. 4 people. Yeah. Yeah. Okay. You are against adopting this right now. Okay. So I guess we should do an adoption call on the list. At least we have offers from a few different vendors that probably are in favor of adopting it, so that also helps. But yeah, I would like to say that right now it's just about adopting this, and hopefully you think it's useful to have a Yang model for this. We can always change the content later if you find that this is all wrong and so on. But we'll do another adoption call on the list then.
Thank you very much.
Good morning, Sanisa again for beer flooding. It will be presented in afternoon beer meeting. Next, please. So let's see the problem statement. It's a typical hybrid network, and different routing protocol runs in different region. So and even in some region, static routing is used. And there are only tens of routers in every region. And we can find that in the circle above, there's only one hop forwarding in this region. And so if we want to deploy beer in this network, according to the existed extension, we can use the IGP extension to deploy in different region and build several beer domain. So you can see beer domain 1, 2, 3 here. So the border router, obviously the border router must convert beer encapsulation, such as MR3, MR4, B1 to B4. So multiple beer encapsulation and decapsulation function will run in the border routers, and it will decrease the efficiency of beer forwarding. Next. So we found that maybe we can merge several regions into one beer domain. So the beer encapsulation and decapsulation times will be decreased. The beer forwarding efficiency will be improved. But there's a new problem. How to build beer forwarding across multiple routing regions? I'm sorry that I forgot to write another figure with the static configuration. So because there's different IDP protocol running in the network, and even static configuration routing be used. So maybe we can give some conversation in border routers. Though it is more complexity, but it may be worked in some regions. But with the static configuration region, there's no IGP routing protocol running in the region. So maybe the existed IGP extension cannot be used. So we'd like to find a solution to solve the every region. So we use a protocol-independent flooding mechanism. The mechanism is defined in PIM source discovery BSR draft in PIM working group. We use this function to flood beer node information in order to build beer forwarding plane. And the extension will be aligned with the SPF ECS or BGP extension. And every node in the domain will build beer forwarding plane according to the beer information and also its FIB. FIB is the forwarding information base table. So we can build the beer forwarding plane without the dependent of IGP, BGP routing computing. Someone will be confused with this draft and the other IGP or BGP extension draft. So this draft will not replace the IGP or BGP BRE extension draft. This function is just a supplement of routing protocol extension, especially in hybrid environment. And we know that BR eliminates PIM protocol states in core domain, but this draft is not backward. We just use flooding function to deliver BR nodes information. And we do not use PIM protocol to building multicast trees. So there's a lot of discussion in the mailing list. And I have talked to Jeffrey yesterday and found that maybe in IGP interoption, it can be a way to solve the IGP interoption. But we think the PIM flooding mechanism may be a general function for this network, especially the network which has the static configuration area. So we want more comments about the function and the IGP interoption function. Maybe this function can be used for general use, and maybe there can be two drafts for the function. When operator can select the right way to use for their network. If the network hasn't the static configuration area, they can use the IGP interoption function. And if they had some static configuration region, we can use this function to for generate solution. So it's a first time introduction of this draft, and we need more comments about this because the network is very commonly used, especially in China. I don't know the situation in other countries, but it's a typical hybrid networking network in China. So we must have found a way to solve it.
So question, Human Nokia. When I was reading the draft, I was a little bit confused, which I think you clarified it here. So you mentioned PIM is not going to be used for any SG estates. You're just using it to relay the beer information.
Yeah, it's we only use PIM protocol, PIM packet to flood the beer node information. And
Okay.
we will not use
you
it
mentioned
to
that
state.
the talks that you had was now going toward IGP. So does it make sense to push this entire thing into the beer working group, or are you guys still keeping it here under the PIM working group?
We think it must include the PIM people and also the beer people to think about it, because we want to deploy beer in the network, but the PIM protocol belongs to PIM working group. So yeah, I think it can be discussed.
What I'm trying to get at is what is PIM really bringing into this solution that something like IGP or BGP cannot solve? I don't understand, like the PIM. When you say flooding, what do you mean by that? You mean multicast? State?
Okay, I can.
Page to the previous.
I can.
Yeah,
I don't know,
the
maybe
problem
add-
statement.
Yeah. So I can maybe add a couple of comments. So one thing is, beer is doing the extensions to OSPF and ISIS, and so they're done in the beer working group. So it's not clear, in this case, whether this would be maybe done in beer as well and not PIM, but that's something we can discuss later. But the only thing PIM is used for here, there's this new PIM mechanism where you can basically distribute some information, like any kind of TLVs, throughout the PIM domain.
Okay.
So the only thing here is there's a PIM message type that allows you to send hop by hop throughout your domain some kind of any kind of information.
Okay.
So it's a little bit like what you might do with an IGP or like say ISIS.
Okay.
So in a way, it doesn't have to be PIM at all. Maybe the message type, the protocol type is PIM, but it could easily be some new protocol type as well.
Yeah. So I guess the only comment is if it's not PIM, and you guys seem to be a little bit open on that idea, then I guess this whole document will be kind of pushed into the beer working group, which makes it a little bit different, right? It seems like it's kind of between two working groups right now. So I'm beginning to wonder if it's cleaner to go one way or the other. That's all. Thank you.
Thank you.
Hey, ice from Cisco. So it's not a bad idea. I think it would solve the problem. But it's not very fashionable these days to have like a separate protocol to distribute this information, as a lot of this information these days is put into the IGP, right? So this would become like the LDP for unicast. This is like the equivalent for beer. So in that sense, it's sort of going in the opposite direction. Yeah, but it's something to think about. But that's my basic concern.
So Warren Kamari without any hats. I mean, it sort of feels like seeing as beer is doing other extensions in beer, maybe it makes sense if this goes forward for it to be discussed there and just to be, strong cross working group discussion and lost called and stuff CC'd here. Just a thought.
Jeffrey from Juniper. I still think that it's better to have the border routers to include BFR ID and subdomain information for BFERs in other domains into the advertisement for this domain. Using BSR has two disadvantages here. One, besides that it's it's PIM based. So first one is that BSR it's refreshing protocol, and the IGP flooding is semi soft states. It's another thing is that the encapsulation information, for example, the MPLS labels for different domain subdomains and different beer sets. Those information is only needed in one domain, and it really does not need to go into other domains. And when you use IGP border routers to carry information for those BFERs in other domains, you can strip those encapsulation related information, and so that brings you more optimization.
Yes, beer proxy is one way to solve it. So we can discuss if the solution can be wrote in this draft or another draft to write on it, and the operator can choose which way to solve their problem. Yeah.
Yeah. So I forgot actually a comment, and it goes in the direction of what Jeffrey said. So have you thought about redistributing the beer information from one IGP into the other?
Yeah.
Right. I think you can do that as well. To solve this problem.
It's like the proxy, beer proxy function and the IGP interoption, right? Yeah.
Yeah.
Yeah. We think, and this function I think is still has some useful. maybe someone can want to use a simple way to achieve the result. So I don't know, but I need more comments about it, and the operator may comment it, and we can go to the thinking about the operator. Yeah.
Another factor to consider is that even though you use BSR to flood that information, you still need the beer or IGP or some beer specific more in the implementation. You still need some code to use the flooded information, and if you use the IGP or BGP to advertise the information, then you already have everything all together.
So maybe one last comment, as we kind of brought it up from operator point of view. Do you foresee operators welcoming PIM again in that network to stitch these IGP areas?
So I made the clarification. We just use PIM function, but we do not use PIM protocol to build a multicast tree.
I think that's understood, but still with the same token, that means you need to have PIM adjacencies between these two IGP area, right?
Yeah.
So again, all I'm wondering is that any operators that you have actually gone forward to, and what is their opinion about bringing PIM back into the network?
PIM has been deployed widely, so maybe they think that the extension can be used easily. Why?
Yeah, you could I don't know, get a new protocol number and call it something other than PIM, but
maybe.
Yeah, no. Anyway,
okay, thank you.
Okay, so just to be clear, the draft has beer in the title of the draft. There's been no request from the PIM working group as far as I know. So this is just an informational presentation to let us know what's going on. In beer. Yeah, okay. Thank you. All right.
Yeah, we're not going to just go ahead with this and PIM. It's really up to beer to say whether they want this stuff.
And that's it. Any other people want to make any comments about anything? Okay, thank you very much. Thank you for coming. Appreciate it. Yeah.
Yeah, thanks.
No, just
so, by the way, so are you kind of taking over for a while, or are you
No.
No, he couldn't make
Yeah,
it.
he couldn't
So,
make it,
yeah,
so
yeah.
good.
Yeah, also thanks.
But I mean, it's also, it does seem. Yeah, like overlap.
Yeah.
That, overall, I have been discussing it with
Yeah.
you, it's just that the spears one.
Yeah, no, we have talked about that.
Yeah.
So
Like,
like you're open.
Okay.
Yeah. So yeah.